Hello, welcome to everyone. My name is Attila Alonso. I'm working as a product engineer for the air conditioning interfaces at Intesis. And today we are going to have a look to the new Fujitsu to KNX interface with 4 binary inputs. This is the product with the connection to the CM port in the air conditioning unit. Okay, so as you can see, I have opened an ETS project and I have already included the database in the project. It's here. And well, one of the novelties of this database that now all the communication objects have been included in different folders here. So it is easier to locate them when doing the configuration. Okay, it's that simple. Okay, coming now to the configuration of the database. As you can see, we have redesigned all this part of the database and included more functionality that is new for this product. Like, for instance, we have included the heartbeat notification here, which basically it's an alive periodical notification to report to the Kns Bus that the interface is alive. And we have the next setting here is the antifreeze thermostat on-off and the eco mode. Basically, those are native functionality of Fujitsu AC units. Okay. So we do have the on-off object to activate or deactivate them. Here, the next parameter is some advanced functionality that we provide with our KNX interfaces. And when you activate the occupancy, window contact, and the sleep function, you will have new menus to configure them. Okay, I'll set the default settings here. And basically, for instance, the window contact, this function basically will switch off the air conditioning when the window is open. Here you can define the polarity of the contact object to get the window status here. Here is the timer, the off timer. Basically, this is the delay between the action, which is opening the window, and the switching off of the air conditioning. We can disallow the on-off operation while the window is open by parameter, and we can reload the last on-off value once the window is closed. When we activate this function, we can set the maximum time to recover the previous window status. I mean, for instance, if you are not interested in recovering the status after 20 minutes, it won't do it. But if you open the window for 10 minutes and then you close it, it will recover the previous on-off status. Okay, that's basically about the window contact. If we come here to the communication objects, okay, I will better show it at the lower window here. Yeah. We will find here different communication objects. Okay, we have 2 binary objects to enable or disable this function and to know the status. We have the sensor or the input. Okay, basically this object is to receive the window contact from the binary input. Later we will see that if you are connecting the window to the interface, you can perform a direct link, so you don't need to use those communication objects. Here we have the on-off locked value. Okay, this is basically will be reporting or will report to the KNX if the disallowed on-off operation is active or not by parameter. And the last communication object we have here is a 1 byte communication object for the status. Basically, this object will report in which stage the the function is in every moment. Okay, so basically this function may be maybe in three different statuses, which are the window is open, the window is closed, and the timer is running. Okay, and those are the three status we can see here. Okay, so moving next to the occupancy functional, it's pretty similar to the previous one because we can perform. Okay, let's start here for the beginning. I will deactivate those functions here. Basically, we will define an action, the action 1, and in this case, we can choose between switching the air conditioning off or apply a predefined temperature delta. And basically, this function is pretty similar to the window contact, but now we are controlling the occupancy of the room. So when the room is occupied, that's is what we could call the normal situation, which is in comparison to the previous function, is like the window is closed. So basically, the air conditioning will be running as usual, but then when the room is empty, when the room is not occupied, this timeout will start running. And after once this timer is lapsed, then the action will be performed. And the action, as you can see here, is maybe switching the air conditioning off or apply a predefined temperature delta. We can set different deltas for the cooling and the heating modes. And after that, after the first action is performed, we can enable a second action here. And again, we can set the two actions between switching off or apply a second predefined temperature delta. And those are the two actions we can do here. Again, we can disallow the on-off operation and reload the last on-off value once the room is occupied again. So as you can see, it's pretty similar to the window contact, but now we are including two options for the action and two actions at the same time. And if we have a look to the communication objects available for this function, again, we have the enabling objects, the sensor objects here, the mode, which is basically the standard data point type for the occupancy, okay, between occupy and standby and not occupied. Standby is compatible or means that the timer are one of the timer is running at the moment. We can report to the KNX if the on-off lock is active or not. Again, and finally we find here the 1 byte status object, which is equivalent to the previous one. But now, as we may have two different timers, two different actions, we may know if the timer 1 is running or the timer 2 is running. And the last function here is the sleep function, which is basically a timer off. Okay, this is the simplest one because you only have to define the timer to switch off the air conditioning unit, and you will have only a 1 binary object to know if or to control the timer here. Okay, this is about the window contact occupancy and the sleep function. If we move forward to the maintenance and remote locking, basically what we have here are different functionalities that we can activate to get the communication objects available for us. Okay, and so you can see, let's start from the beginning. We have the filter. Okay, I will deactivate them so you can have a look easier to them. The first communication objects are the filter, and here we have two different objects, the status and the control. Basically, when the functioning is very simple. Once you have an alarm through the status filter object, okay, then the maintenance guy will be will clean the filter or replace it, and after that, the control the filter alarm should be reset using the control object. Okay, it's that simple. We do have the error notification to the Kns Bus, and here we have the 1-bit object to know if there is an error active in the HVAC system. The 2 bytes error code. Basically, this is the error code that the air conditioning is reporting. And this is the character string in 14 bytes object, which is basically the previous error, but now offered into a different communication object. Okay, moving forward, the operating time counter. In this case, we have 4 communication objects, two objects for the control, 2 objects for the statuses, and 2 are reporting hours and 2 are reporting seconds. Okay, the remote locking. This object will lock the native air conditioning remotes. Okay, so when you are not interested on having the control available from the AC or on the Fujitsu remote controller, you can simply lock it using those objects. And it's something similar that we have here with the KNX control lock. In this case, what we are controlling is the communication objects of for the AC control here, the on-off object, the operation mode object, and so on. Be careful when using this object because sometimes you can lock it and don't remember that the control from the KNX has been locked. So review it or check it before considering other sources of the problem. Okay, so let's continue with the database here. Then the next setting here is the scenes and additional modes, and this is something new in this database because now we are combining the scenes and some advanced functions at the same time. This database provides up to 10 scenes, okay? And to do the configuration of the scenes, you have to enable in general section, then come here, and then enable the number of scenes or functions that you want to use. Okay, I will decrease the total number of scenes available. And as you can see, once you enable one of the functions, you will have available the settings or the parameters for the scenes. Here is the scene function A, B, and C. Here you can define the scene number. Let's say, suppose the scene number 10. And here we can add a description like the day scenes or the daily scenes or whatever. Okay, this is something equivalent for any scene. And then to configure the scene itself, you have to come to the scene or functions and select here what you want to use. By default, we are considering scenes, and here you can have a look all the scenes parameters that you can control: the on-off, the mode, the set point, the fan speed, vanes up, down, and left, right, and the remote locking. Okay, if you want then user to be able to modify the scene, you can, or you have to keep this checkbox activated. Otherwise, the scenes you configure here, it won't be modifiable from the communication objects in runtime. Okay, be careful using this because probably you are interested in changing or modifying the scene or not doing so. Check it before downloading the device, the configuration in the device. We can enable, or it's possible to enable a 1-bit communication object to activate the scene. I will show you. We are here. Okay, basically we are activating this object. And finally, one different settings we have included here are the timer options. So by using those timers, we can delay the scene execution and we can set a duration, let's say a timer. For instance, if we want to run the AC for 20 minutes working in dry mode, you can trigger or configure here and scene like that. And if you want to do it for 20 minutes, you can simply do that. So that is an scene which will be activated in the dry mode for 20 minutes. And after that, it will recover the previous AC status, okay? Probably when you are, let's suppose, when you are triggering those scenes, you want to lock the control from the AC remote, okay? But that depends on the specific situation. Okay, what else? What else we have in the scenes configuration? Okay, so sometimes we are providing some predefined functions like the power mode, the echo mode, the additional heat, and additional cool. Okay, basically those are predefined functions. Again, we will have the possibility to activate or deactivate the execution with a one-bit object. But also we can define the delay and the timer, the duration of the function here, and a few parameters. Because, for instance, the power mode normally will activate the current mode to the maximum. And you can define, you have some few settings here available. It's important that when we are configuring functions, we cannot, let's say, we cannot modify the function in runtime. So let's suppose that you set the fan speed 6, but then you realize this is too high for your application. So probably you are interested in setting the fan speed 4, let's suppose, and you have to come back to the parameters and do the download from the ETS here. Okay, you cannot change it in real time. So yeah, that's the power mode. The echo mode is similar to that one. And finally, we have the additional heat and additional cool, which normally, or let's say those functions are widely used when the HVAC system is a supportive or a secondary system over a primary. So then you will have the possibility to set in the duration of the additional heat or additional cool, or simply set it an endless, and this will be controlled by the let's say the original thermostat, KNX thermostat. Okay. So yeah, that's about the scenes and functions. Let's continue with the binary inputs. Basically, well, first thing will be enabling the desired inputs here. I want to go so deep on the binary inputs configuration because this is common. This is some, let's say, like the parameters here are basically the same we have in every KNX interface. So you can configure switching, a dimer, a shutter or blind, or you can configure the binary input to send a specific value, a fixed value to the KNX. And again, we have the internal links to activate the function scenes, the occupancy, and the window contact. Okay, this is what I was referring to when doing the scene configuration, because you can perform the internal link here, and that's all. You don't need to link any communication object to activate the function or the scene from the binary input. You have it is available one non-binary object here, simply to know the binary status at any time. But this is just for your for the integrator reference. It's not to activate or deactivate the functionality itself. Okay. One interesting setting here is the ambient temperature. When we are using the thermostat, the KNX thermostat, and we want to use the ambient reference or from the thermostat to be applied on the AC unit. And I will come here to temperature objects to show it. Okay, let's suppose the normal situation, which is the one similar to having the AC system isolated or controlled by their own remotes. So basically, in that case, we do have those possibilities, those communication objects, which will be modifying the set point temperature of the air conditioning unit, and we will have this status object to know the set point at any time in the AC unit. And the last object, the 125, is the AC reference temperature. Basically, this object will be reporting the temperature measured by the AC unit. Normally, this value corresponds with the temperature probe located on the return path, but that is something that depends on the AC configuration. Sometimes it may be the temperature of the wired remote controller of the Fujitsu unit or any other. Okay. Yeah, that's the normal situation. But when the installation requires to use a KNX temperature probe, we activate different objects, which I will locate here, which are those three. Okay. So again, the set point objects are still available. Okay. So let's start for the new communication object. This is the control KNX ambient temperature. Basically, this object is to receive the temperature measured by the KNX thermostat or the KNX temperature probe, whatever is located. The next object, the status user set point temperature. In this case, this object should be used to feedback the KNX thermostat. Okay. I will explain later why, but basically this object will be reporting the set point that the user is including here. It is setting through the control set point temperature. This is the 1-bit status object to know if the virtual temperature is active or not, because sometimes you can enable this function here, but if no temperature is received from the KNX thermostat, the function will not start working. And yeah, basically the virtual temperature works in the following way. Fujitsu doesn't allow to modify the reference temperature on the AC unit from the interface. So what we do is to moving the different temperature that there is in the room where the KNX thermostat and the interface are located. And we translate this temperature difference to the AC unit, considering the reference of the AC unit and modifying or acting over the set point. Okay, the set point that the user sets will not be, or does in the majority of the cases won't match with the real set point in the AC unit. And we will have a look now. Sorry. For instance, let's suppose that we have 25 degrees on the measured in the room, and the user sets the AC to 23 using this communication object. But the AC is measuring 27 in the return path, okay? Because probably the there is an airflow close to the temperature proof, or the return flow is not the best. So as we can see here, if we do have a 2 degrees difference between the ambient and the desired temperature, and the AC is measuring 27, but if we set directly the AC to 23, as the user decided, the AC will try to decrease the temperature in 4 degrees, from 27 to 23, because the user set the AC to 23. So what we will do is, instead of setting the AC to 23, we will set the AC to 25. Why? Because there was 2 degrees difference here, and we will move that difference to the AC. And so the modified temperature, set point temperature, will be reported by in this status set point temperature, which will be reporting the real set point in the AC unit. And this other, the user set point temperature, basically this will be reporting the set point that the user set using the control object. So this is to feedback, in this case, the thermostat, and this is for your own information. Moving forward, we have the AC unit features. Basically, we should, or it is necessary to configure this part with the capabilities of our AC unit. Okay, so for instance, if our AC unit has had 3 different fan speeds, you should deactivate the ones which are not available in our AC unit. How to know which are available or which are not? You can consult the operation manual of the AC unit, or you can also go straight to the wired or wireless remote controller and see the options available for the AC unit. The same for the vanes up down and the vanes left right. It is also possible to deactivate different objects or different operation modes, coming here and simply deactivating. Okay, this will basically simplify the configuration later, but it's important, in special referring to the fan speed, as it will apply, or it will modify the different ranges available in the fan speed objects. Okay, let's continue. Now what we will have here are the different or specific parameters for the mode, temperature, fan speed, vanes up, down, and left, right. And yes, basically it's activating different objects, like for the mode, cooling, heating, or the 1-bit object to go through all the operation modes available in the AC unit. We can define here the polarity of the object. If we were interested in having both, we can activate it. In advanced mode setting, we can activate the 1-bit mode objects. And here there is an interesting setting, or an interesting parameter, which is the PID compatible scaling mode objects. Basically, those objects are, let me find them, and they are here. Basically, those objects will turning on the AC unit and setting heating or cooling, depending on the specific object. Normally, in many KNX thermostats, when they are offering some PID control objects, for instance, for a fine coil controller, you can use those objects and link it to those. Okay, so when you are doing that, it's not necessary to use the binary on-off objects, because this object will directly switching on/off the AC, and it's not necessary to use the control mode, because it will be changing between cooling and heating, unless you want to set any other mode. Okay, moving forward, the temperature, we have now the possibility of setting different temperature limits, setting here in parameters, but later you can modify them using the communication objects. Okay, very quickly, we can set a periodical sending of the status of set point temperature. That will be something that some KNX thermostat requires to receive periodically the set point temperature. We can set how to transmit the status AC reference temperature, basically the temperature measured in the AC unit. We will define here how we want to report it to KNX. Okay, we can do it cyclically, on change, or both, and set here the period of time for the cyclically sending. Okay. Here we have some very advanced functions, I would say, because we have the set point temperature AC range objects. This is something informative. Basically, some AC units or some system may have a lower temperature range available, and we may know the maximum and minimum set point temperature available in our AC unit by using this parameter here. Basically, this is something informative. So if you see, let's say, an 18 here in the minimum, the AC cannot be set lower. And finally, we have the applied set point temperature limit, and this is just to inform which set point, which limit is active at any time, because depending on the set point limit set in the objects here and the capacity of the AC unit, okay, the more restrictive within the temperature limit set here and the capacity of the AC unit will be the applied set point temperature limit. Okay, moving to the fan speeds, we have here the possibility to enable the scaling the numerated of both objects at the same time. We can use the 0 to set the auto fan. Okay, this is to take advantage of, I will show you here, to take advantage of the KNX thermostat, because sometimes they can activate the auto fan by using the 0 value. So we can offer this possibility in our interfaces. Here we have a 1-bit object to increase or decrease the fan speeds, and we have the possibility to activate the 1-bit objects for the different fan speeds. Again, be careful before moving to the fan speed configuration. Check that the fan speeds available in your AC unit matches with this configuration. Okay, because this will affect directly to the communication objects available, also to the fan speeds available in the 1-byte object, and this is important to have it properly configured. Okay, it's the same for the vanes up down. Okay, basically it's the same, but now for the vanes. And that's all from my side. If you have any suggestion, any doubt, just let us know, and hope to see you in next video tutorials. Bye bye.